algebra. All right, so guys, what we spoke about, and if you are new, don't stress. Like Elaine said, all of the lessons are recorded, and so whatever you've missed from this course, you can definitely go and watch online. But what we have been speaking about so far in algebra is just the basics of simplification. So we've been chatting, especially in the last lesson, about this idea of like terms. And so just as a reminder, because we're going to carry on using like terms all the way through our algebra sections. Like terms are terms that have the same variable and exponent. Now, it's very important that we are able to identify like terms, because when I start to add and subtract terms, I can only add or subtract like terms. And so when we look at an expression, we need to be able to identify those like terms for ourselves. Now, I like to use a highlighter. So if you guys like to be able to highlight your like terms, please do that. If you want to underline them, have colors going, whatever you need to do to help yourself identify your like terms. It's very important that we do that. And so what we've so far spoken about is adding or subtracting like terms. Now, like terms are only important when we add or subtract. What we're going to chat about today is the operations of multiplication and division. And this is now where, and we've spoken about this many times before, where SNV comes in. Now, SNV, whoops, sorry, don't know what happened there. SNV is signs, numbers, and variables. And this is very helpful for us to make sure that we are multiplying and dividing values correctly. So this is useful for us when we multiply and when we divide. Alrighty, so we've looked at the operations of addition and subtraction. We're going to have a look at multiplication and division today, and then what we're going to eventually do is combine all of those operations together in order to simplify our algebraic expressions. So one thing I want to remind you, because we are going to do multiplication and division today, is just, sorry, I turned off my video, is just this idea of what we actually are working with when we have a variable and a number together. So if you have a look at this block here, we have got the term 2x. Now, what we need to understand is that this is saying 2 times the variable x. So this is actually a product between the number 2 and the variable x with times in. And each part of this term have a special name or have a specific word that we associate with it. So the variable part of this we already know is any letter that we have that represents an unknown in our expression or in our term. And then we have this coefficient. Now the coefficient is the number in front of our variable. And we've spoken about this a little bit already, but remember your coefficient can really be anything. So we could have a coefficient of -3 being multiplied with our x. We can have a coefficient of 1/2 being multiplied with our x. But anytime we have a variable, we do have a coefficient. And this is what we spoke about in a couple of our last lessons, where if you just have a variable sitting by itself, it's got nothing that we can see in front of it, it does actually have a coefficient of 1. So what we need to remember here is that anytime we have a variable, we will always have a coefficient. Sometimes that coefficient is a number that we write down, but sometimes that number is a coefficient of 1. Now that is very important when I start adding and subtracting like terms again, because we know that if we've got 1x and we're adding it, say for example, to 2x, we're going to end up with 3x's in total. So it's always very important to understand what our terms are saying to us. Alrighty, but let's have a look at how we can start to simplify some of our expressions when we now start to deal with multiplication and division. Alrighty, guys, excuse me. To start off with, I just want to remind us, or remind ourselves of what terms are. So we're not going to necessarily spend too much time on this, but what I want to do is I'm going to ask you to put in the chat for me how many terms each of these expressions has. So let's start with the first one. So if we look at A, my question to you is, how many terms are in this expression. Now remember, we spoke about this a little while ago. Terms in an expression are separated by plus and minus signs. So that's what we need to look out for when we are trying to identify terms. So I want to see in the chat how many terms you think question A or expression A has. Orlando's already put an answer there for us. So guys, in the chat, I want to see how many terms you think A has. Edwina, good, seeing the answers. Tandawake, very nice. Keep them coming, guys.
We can do this, my people. Let's go.
Nice. Okay, good. So guys, this only has one term in this expression. There are no plus or minus signs that separates my terms. And so I've got one term in this expression. If we now compare this to expression B, so Latemba, have a listen now. If we have a look at B, we can see that we've got a plus sign over here. Now, if we go back to our definition of what terms are separated by plus or minus signs. So this plus sign that I have over here is actually separating my two terms of the expression. It's telling me that I've got one term of 4a and a second term of positive 3b, which means that in this expression, I have got two terms because that plus sign is separating my terms. So based on that, based on what we've just spoken about in terms of being able to identify terms, in the chat for me, tell me how many terms you think expression C has. So look out for those plus and minus signs. Okay, grade 8, I'm asking you how many terms does expression C have? We've done B, we've said B is two terms. We've done A, we've said A is one term. So I would like to know how many terms are in expression C.
There we go, my people. I see nice answers. Yes, guys. I think the internet is a little bit slow.
Right, guys, very nicely done. Okay, so if we have a look here, there's my plus sign, there's a minus sign. The second I see those signs, it's telling me that it's separating terms in my expression for me. So I've got one term of 2x squared. I've got another term of positive 3y squared, and I've got another term of negative 7z cubed. Sure, panic. So in this expression, I have got three terms. And I know that because I identified where my plus and minus signs are. Oopsie. And from there, I could say I have three terms. Alrighty. So those are quite simple to start off with. But now it's when we get to the operations that we're going to deal with today that we need to be quite careful. So if we have a look at our next expression in D, what we have here is 3 times the bracket 2x plus 5. Now, if I look inside the bracket, I have got two terms because inside my bracket, I have got the expression 2x plus 5. That plus sign is separating my two terms that I have here. But I'm not looking at what's only inside the bracket. When I have an expression where there's multiplication, I am looking at the entire thing and I want to know how many terms there are. Now, importantly, if we again go back to our definition of what terms are only separated by plus or minus signs. Division and multiplication do not separate terms. So I'm going to say that again. Addition and subtraction separate terms. Multiplication and division do not separate terms. Now, what that means is because this expression is basically a multiplication, I actually only have one single term in my entire expression. Yes, inside the brackets, I've got two terms, but I don't want to look at what's only inside my brackets. I want to look at the entire expression. And because multiplication and division don't separate terms, I only have one term here. So don't separate terms. Alrighty, so based on that, based on what I've just said about multiplication and division not separating terms, I want to know how many terms you think E has. So look at E, you've got a whole fraction of your numerator 2x minus 5 and your denominator over 3. How many terms do you think the whole expression in E has? Dial, my screen is not supposed to be black and blue, so you might need to log out and log back in again.
Yes, please.
Okay, we've got a bit of a mixed batch. Let's see some answers keep coming through.
Let's see who's correct. Let's go. Vote, guys, everyone, let's go. Let's do this. Which one? How many terms? Let's go. And remember, you must correct, okay? After when teacher Sam tells us the correct answer, please correct and understand why you are wrong or why you are right, okay? Y'all are doing amazing.
Alrighty, guys. Okay, so there's a bit of a mixed bag coming in here in terms of answers, which is absolutely fine. When it gets to fractions and multiplication, it is a little bit harder. And so this is why we're discussing this before just jumping in. What we need to realize is, what we need to realize is that if we just looked at the numerator, so if I ignored that denominator and looked at my numerator of 2x minus 5, then yes, I would have two terms because the minus sign is separating those terms. But we cannot just ignore the denominator. And so what we have here is the whole numerator divided by a single denominator. And because I've just said that multiplication and division do not separate terms, this fraction doesn't separate terms for me. What I actually have here is one whole term that is a fraction. And so in both D and E, I only have one term that I'm working with because, multiplication and division don't separate terms. Now, once again, it's very important that we understand this because today we're going to look at multiplication and division. And what we need to understand is that we always want to deal with our multiplication and division first, because that's what BODMAS is. But it also is important because you can't start adding or subtracting like terms until you've dealt with your multiplication and your division. So it's very, very important that we see our terms in our expressions before we start to just add and subtract like terms. So I'm going to leave this here for a second so that you can screenshot, and then we're going to start to look at some examples using those two operations of multiplication and division. And guys, it's absolutely fine if we forget about the rule of terms. We haven't done terms or algebra in quite a while. And so this is just like a bit of a refresher for us. And this is why I say to you, we're doing this very slowly. But as you start to move up in algebra, we don't focus as much on the basics, just because once we've taught you the basics, we sort of assume that you know them. And so this is why I'm going through this algebra course quite slowly, because eventually your teachers are going to assume that you know what a term is and how to identify them. And so this is why it's really important that we focus now on being able to understand this stuff. So those of you that don't understand, take your screenshot. And as we go through examples, I'm going to reiterate, or I'm going to re-explain this idea of terms and what we do with examples. And hopefully that'll make a little bit more sense as we go along. Alrighty, so I'm assuming, golly, I'm assuming we all have screenshots. I'm going to scroll down now to some examples that we're going to work through. We're going to do some together, like Yolanda said. I'm going to let you do some by yourself. Please don't rush ahead and do examples that I'm not on or haven't asked you to do, just because you're going to start confusing the situation. So right now, I am looking at example A. Ignore example B. We are on example A. Alrighty, guys. So in example A, what we have going on here is 4 times the bracket 2y plus 3. Now, when we are identifying terms, so when identifying terms, we don't look at the plus or minus signs inside the bracket. That's starting to look a bit weird. We don't look at plus or minus signs inside the brackets. And this is because they are inside the bracket. Because they are inside a bracket, they are going to have either something multiplied to them or something divided into them before we start adding or subtracting. So when we start to look at terms, we don't look at plus or minus signs inside the bracket. So you can almost think of this as 4 times the bracket, and just ignore what's in the bracket for a second. This is because what we're trying to do, remember, is identify our terms. So when we just look at 4 times the bracket, I don't have any pluses there separating the 4 in the bracket or a minus separating the 4 in the bracket. And so what this means is that this entire thing is one term. Yes, inside the bracket, I've got 2 terms, but I don't care about that right now. I care about the fact that I'm saying 4 times something, and times doesn't separate terms, and so I have 1 term. So once I know how many terms I'm working with, I can now go and simplify my terms. Now, what that means is I need to take this coefficient to the bracket, which is 4, and I need to multiply that to both of the terms inside my bracket. So if we have a little multiplication box going on the side here for our working out, the first thing I want to do is say 4 times positive 2y, and then I want to say 4 times the positive 3. Those are the 2 multiplication steps, or the 2 products I need to find. Now, when I multiply any terms together, once again, this is where we need to think of SNV, signs, numbers, variables. Now, if I look at the 4 times 2y, my signs, I've got a positive times a positive, so my answer is going to be positive. If I move on to the numbers, 4 times 2 is 8. And then I just have my variable of y. That's not being multiplied, but by anything, it just stays as it is. If we then look at our next product, we have got positive 4 times positive 3. So our signs is positive times a positive, which means we have a positive. Our numbers is 4 times 3, which is 12. And I've got no variables here. So the variables, or the V in the SNB, doesn't really matter. And so what we can now do is we can write these products down. I had 8y from my first multiplication, and then the plus 12 or positive 12 from my second multiplication. And so through the distribution, or through multiplying the 4 in front of the bracket with the 2y and the positive 3, I have simplified, which is what the instruction told me to do. I have simplified this expression. So sometimes what needs to happen is we need to be able to distribute, or we need to be able to multiply a number in front of, or even like in question B, behind the bracket, in order to get our products before we continue. So what I want you guys to try is question B. Now, just because this 4 is sitting at the back of our bracket, it doesn't change the meaning. We still have a bracket times 4. So we still have, we still have 1 term that we're working with here because it's multiplication. And we still therefore want to multiply the 4 into our bracket. So give it a try, see what you come up with. Put your answers in the chat. and then we'll have a look at our answer. And I saw an amazing result there from Mwamba. I hope I'm saying your name correctly. 49 out of 50 for the maths exam. That is excellent. Well done. So guys, give this a try. Let's see what we come up with. You do have a variable there, so your answer should still have a variable because we can't just lose a letter.
Let's go, my people. We can do this.
Okay, and I'm glad some of us are focused.
Let's go, guys.
Good, grade 8s. Well done. Okay, so hopefully what we're seeing, I'm just gonna make this touch more smaller, is that we get exactly the same answer of 8y plus 12. And the reason we get exactly the same answer is because this is exactly the same question. If we have a look at the two questions that we had 4 times a bracket and 4 times a bracket. We know that it doesn't matter whether I say 3 times 2 or 2 times 3, I still get an answer of 6. And so the point of these two examples, A and B, is to show you that the order in which we multiply doesn't matter. And so it doesn't matter if your coefficient is sitting at the back of the bracket. As long as there's no sign in between that number and the bracket, you are still multiplying into your bracket. And so trying to think of the word that I'm looking for. And so the method or the steps still remain exactly the same. Right, now, very importantly, guys, these are not like terms. It's actually maybe just a nice red here. These two terms are not like, I'd help if I could spell like, terms, which means that we cannot add or subtract them. So we cannot get 20 or 20y because they are not like terms. They can't be added or subtracted, so they stay 8y plus 12. That is it. Alrighty, that is very, very important. Please remember this. I'm actually just going to highlight this as well, just to be a little bit extra here. They are not like terms, so you can't add and subtract them. If you start adding or subtracting like terms, you're making up some other kind of maths that doesn't exist. So don't do that. Right, I'm gonna let you take a screenshot of that, and then we'll do one more before we take a brain break. Right, so I will make this a touch smaller so that you can see what we were doing in A and B. I want you to try C for me. So question C is what I want you to try. I want you to put your answers on the chat. If anyone has a question at this point, now is the time to raise your hand to ask me while everyone's trying question C. Otherwise, I'm waiting for your answers in the chat, and I will get some hands when we are ready. So remember, think about what that 4 in front of the bracket means. Look at the examples that we did in A and B, see what we did with the 4 in front of the bracket, and follow that method. And guys, almost like what I did in question A, if you need to have a little block for yourself where you are doing your multiplication on the side or you're working out on the side, that's absolutely fine. No problem whatsoever in having some space on the side or even just having a separate piece of paper to do your working out on. Remember, guys, this isn't an equation, so we shouldn't have any equal signs going on. We are going to get to equations, but right now, what we are dealing with are expressions.
You guys are doing really well. Sorry to just say, you can go.
I was just going to carry on about we're not dealing with equations.
They're really doing well. Remember, the goal is to mark, my peeps, my people. We need to mark our work, okay? So hopefully you have written it down on your book so that you can correct, okay? Nice, guys. You keep them coming so we can do corrections.
And guys, just another thing quickly. What you can see is once we multiplied the 8 or to get 8y and 12y, I still had a sign in between them. So there should still be signs in between your products because a product will either be positive or negative. So you shouldn't just have everything lumped together. There should be signs between your products. Amazing. Okay, who would like to raise their hand to explain for us how they did this question? Okay, Cassie, help us out here.
So I see 4 times 2x is 8, 4 times 3y is 12, and then 3 plus 1, which is 4.
Okay,
so
what about those variables?
Ma'am, I added them in front of the numbers.
Okay, so you got 8x, 12y, and then 4.
Yes, ma'am.
Perfect. Okay, cool. Carry on.
Yeah, ma'am, I'm not that far yet. I only did number C.
Okay, perfect. So guys, exactly what Cassie's done here is perfect. We multiply the 4 to the 2x, we multiply it to the 3y, and we multiply it to 2, and I obviously can't draw an arrow very well, and we multiply it to the 1. So I've just done my little multiplication block or my little working out on the side here. Remember SNV. Remember to check your signs, check your numbers, check your variables. And so as Cassie's got here, we've got 8x as our first product, plus 12y, because remember, positive times a positive is a positive. So plus 12y, plus 4. Now there's no like terms. So again, this links back to what we said here. These are not like terms. And so that means I cannot add or subtract them. So my answer is 8x plus 12y plus 4. If I had like terms, then yes, we can add or subtract. But in this case, I don't. And so I stop. Alrighty, so I'm going to wait here. Let's just maybe do this so that you can still see A. I'm going to wait here for you to take screenshots. If anyone has any questions, you may raise your hand now while we're taking screenshots. And then we'll have a little brain break. Blessed, question?
Ma'am, so I was asking, we always time here at C we times with four to these numbers that are there, ma'am.
You broke up a little bit, so I think I heard we take the 4 in front of the bracket and we times it to the numbers in the bracket.
Yes, ma'am.
Yes, we do.
Thank you,
Good.
ma'am.
Okay, and guys, like Yolanda said, once we go through questions, make sure you are marking your answers as we go along. Because I saw some answers that were very close, but some answers that were a little bit off. So make sure you have marked your answers. Alrighty, brain break time. So again, someone had asked for some fractions practice. So here's our fractions practice over here. Clearly got a bit excited about what was going on. Yeah, right. So this is our brain break for today. It's going back to our fraction section. So you need to think back to all of the stuff you know about fractions. The question says Fiona has some sweets. She gives a quarter of them to Michelle, and she gives a sixth of the remainder of them to Nina. If Fiona has 25 sweets left over, how many did she have in the beginning? So have a think, have a try. I know fractions is sometimes quite tricky. So like Cassie says, sometimes we really do struggle with fractions. And this is why I've made out some of our brain breaks fraction word problems, because we do struggle with them and because they do come up. It's nice to give them a try and see how to handle them when you do face them. So have a go, have a think. Write it down. It's often very helpful to take what you have and write down your working out, even if it's scribbles, give it a try.
Let's go. That's an interesting one. Let's go, my pebs. The joke. Hi. Oh.
Guys, just remember to read your question carefully. The question is asking you, maybe we should just highlight it for ourselves. The question is asking, how many sweets did she have in the beginning? Which means that your answer should be a whole number. You can't have 1/24 or 1/8 or 1/4 or negative 2/3 of a sweet. It should be a whole number. And I'll give you a hint, you are not just multiplying those fractions together. I'm going to give you another minute or so. If we don't get an answer, I'm going to make you take a screenshot and give it a try, just because, again, these are the sorts of questions we can ask you. And it's those sorts of questions that in a test that you see and you feel a bit panicked about them. And so we generally just leave them out and then we become stressed out about the rest of our test. And we don't want to do that. We want to be able to look at these and either not get flustered and just move on from them, or be able to give them a try. So I'm going to give you another minute or so. Haven't seen any correct answers just yet. Again, you should not be getting a fraction answer. Your answer is not a fraction. Your answer is a whole number. Okay, grade 8. So take a screenshot of this. I want you to go and have a think about how you think you would go about dealing with this. And then on Wednesday's lesson in our brain break, we'll have a look at this question. Again, this is something that we need to be able to do. It works with fractions and the concepts that we know about fractions. And I'm going to say it for the third time, your answer is not a fraction or a decimal, your answer is a whole number. So keep that in the back of your mind when you give this a try for me, but take your screenshots. Mapei, I'm not too sure why your hand is up because I haven't asked for hands, but do you have a problem or a question?
I would like to say,
Sorry, say again.
I would like to answer, sir, ma'am.
Okay, you can try.
The answer is 30.
Okay, very close, but not 30. She's got a little bit more. So I want you to go and take a screenshot of this and give it a try, and then we'll have a look on Wednesday at what we think the answer is.
Nice
Right.
try, Mapo.
So 30 is
Never
close,
hope.
but
Yeah.
it's not 30. It's close, but not 30. So take your screenshots, and then on Wednesday, we'll have a look at how we deal with these sorts of questions. But it's good to give this a try. So that's why I want you to take a screenshot, give it a try, and on Wednesday, we'll mark, or you will mark rather, what your answer was.
We're packing it, guys. We're packing it. Well done for trying.
Remember, you can actually do this without a calculator, just because the fractions that we're working with, you can multiply or divide, add or subtract them quite easily without a calculator. So don't stress, you should be able to do it without a calculator. All right, guys, but let's go back. And what I want you to have a look at now is this question that we have in question D. Now, this is a little bit of a step up from what we were chatting about. If we go back to question C, again, what I have here is 4 times a bracket. So once again, I've got one term that I'm working with here. But now all of a sudden in question D, I see that there is a plus sign outside of my brackets. Now remember, over here, I said that when we identify terms, we don't look at the plus or minus signs inside brackets, but we do care about the ones outside brackets. So in question D, we have got a plus sign outside of our brackets. Now that is very important because it means that I've got 2 terms in this expression. There's my first term and there is my second term. Oh, whatever. Now what that means is I need to deal with each term separately. So let's make a little note here. When we have more than one term, we want to simplify each term separately. Okay, now when I say we need to simplify each term separately, what I mean is that we need to look at the coefficient of our first bracket, which is a 2, and that is only multiplied to the bracket it is right next to. So that is only going to be multiplied with the x and with the positive 2. In my second term, so completely separate from that, I then need to take this positive 3 and multiply it to the x and multiply it to the 1. They are separate terms. We deal with them separately. So we've got 2 separate multiplications that we need to do here. So that is what I want you to try first. I would just want you to multiply the 2 into the first bracket and the 3 into the second bracket. If you feel comfortable and confident that you can carry on simplifying, that's absolutely fine. But I want you to just, to start off with, to multiply the 2 into the first bracket and the 3 into the second bracket. And you can put in the chat what you get when you multiply those things into the bracket. So remember, I'm just asking you to distribute into the bracket there.
Take your screenshots while you're busy working. I see some answers coming in. Let's go, my people. Let's go. Do this.
Good, guys. Keep them coming. That's all we block. Let's try that again. All right, some people are missing some terms here. All of a sudden, we've got a Z somewhere. So let's have a look, grade 8. So if I look at my first bracket, so this is my orange block. This was the bracket 2 times x plus 2. So I've got 2 times the x, and we've got 2 times the positive 2. Now we always want to remember signs, numbers, variables when we multiply. Here I've got a positive 2 times a positive x, so my answer is positive. And I've got 2 times, now remember I've said to you that there is always a coefficient to any variable, so there is a 1 in front of that x. So we've got 2 times 1, which is 2, and then we've got the x there. So 2 times x is 2x. Then we've got positive 2 times positive 2. Positive times a positive is a positive. 2 times 2 is 4. I've got no variables there, so it's just 4. So from my first bracket, I've got 2x plus 4. Then when I go and multiply my second bracket, which was positive 3 times x plus 1, I've got 3 times x, and I've got 3 times positive 1. Positive times positive is a positive. 3 times, and remember there's a coefficient of 1, so 3 times 1 is 3, and then I've got my x. Positive 3 times positive 1 is positive 3. So from my second bracket, I've got a positive 3x and a positive 3. So I need all of you to please check your products there, because there were some interesting looking products that were coming in on the chat there. And guys, we need to make sure that we're multiplying or distributing correctly. All right, so now what I need to check for is I need to check for like terms. Now, I've already told you what like terms are. We wrote it down earlier. Like terms are terms that have the same variables and exponents. So here I can see that I've got a 2x and a 3x, which are like terms because they both have a variable x with an exponent of 1, as well as a plus 3 and a plus 4. Those are my constant terms. We've spoken about that as well. If you've missed that, you need to go to, I think it was the first lesson that we did in this course. We spoke about all of these definitions. So go back and have a look. So now what we need to do is we need to say 2x plus 3x. I'm just going to group my like terms. And then the plus 4 plus 3. So these are the like terms that I need to add or subtract. So 2x plus 3x, I have 2 x's. I'm adding another 3. That gives me 5 x's in total. And 4 plus 3 gives me 7. And so once I've checked and added my like terms, I've got my most simple form of my answer. Now, once again, I really sincerely hope that all of you were checking your work, all of you were correcting your work, because importantly, we had 2x plus 3x, not 4x plus 3x. And a lot of you were saying 4x. So I need you to make sure that you have not written down something incorrectly and you have done your corrections.
Yes, my people, you must always do your corrections.
Please. Right, guys, we've got like a minute or two. So if anyone has any last questions they would like to ask before we end off, otherwise you are doing the poll that is up. You are not to leave until that poll is done.